Alright, so now in this video let us discuss about functional dependencies, right? So first let us look at the definition of functional dependency, then we will understand what is a functional dependency, right? So a functional dependency denoted by x determine y between two sets of attributes x and y specifies that for any two tuples t1 and t2 in any state of the relation schema R that have t1 of x is equal to t2 of x, they must also have t1 of y is equal to t2 of y. Or we also say that x functionally determines y in a relation schema if and only whenever two tuples of R are agree on their x value, they must necessarily agree on their y value, right? So this is the definition of functional dependency, right? So what is a functional dependency? Functional dependency between two sets of attributes x and y states that x can functionally determine y, right? So this sign x, this is read as x functionally determines y or x determines y. So what do we understand from this? X functionally determines y means the values of x have the ability to determine the values of y, right? Where x and y are two subsets of attributes of a relation schema, right? So if a relation schema has two subsets of attributes x and y, then x determines y states that given the value of x, we can give the value of y, right? So how is it possible? It says that let us say x and y are simply two attributes. Here we are talking about two sets of attributes x and y. Let us say x and y are two attributes, right? So what functional dependency x determines y states is given the value of x, we can determine the value of y. So how is it possible? Let us say the value of x is 1, y is a, x is 2, y is a, 3 and y is b, let us say, and x is 1 and y is b, right? So let us say these are the given values. So we have to see whether x determines y, right? Let us look at this first, okay? So what is it saying is given the value of x, you should be able to give the value of y, right? That is what is the meaning of this. So let us say the value of x is given as 1, right? So x is given as 1. Can you uniquely say the value of y? Right? If I say that the value of x is 1, can you tell what is the value of y? The value of y is a. Right? Y's value is a. So we can say that x functionally determines y. But we cannot directly say it. First we have to cross check for the second value of x, right? So now second tuple for which x remains 1, right? So let us say this is the tuple. So this is the tuple where x is again repeating, x is again 1, so y is again a, right? So whenever x is 1, y is a. So x can functionally determine y, right? Also you can see that given the value of x as 2, we can uniquely find out the value of y as a, right? Given the value of x as 3, we can uniquely say that the value of y is b, right? Let us say, but if this is not the case, let us say we have one more tuple whose x value is 1 and y value is b, right? So given the value of x as 1, can we uniquely say the value of y? Given the value of x as 1, can we uniquely say the value of y? No, because here when x is 1, the value of y is a. Here when x is 1, the value of y is a. Good. But here when x is 1, the value of y is b, right? So given a single or unique value of x, we are getting two values of y, right? So x is unable to uniquely determine y, right? So given what is a functional dependency? Functional dependency says that given the value of x, we must be able to determine the value of y. But here this case is not holding. Here this condition is not holding. Why? Because given the value of x as 1, we are unable to uniquely determine the value of y, right? So we are getting two values of y, right? So this is not a this functional dependency x determines y doesn't hold here in case this tuple is also a part of this particular relation schema, right? So we say that this doesn't hold, right? So that is what, and if I say that x determines y holds on this particular relation schema, then it means that given the value of x, I can uniquely determine the value of y. So that is what is written, that a functional dependency x determines y between two sets of attributes x and y specifies that for any two tuples t1 and t2 in any state of the relation schema that have t1 of x is equal to t2 of x must also have t1 of y is equal to t2 of y. What it means is, whenever we say that x determines y, it says that if we have two tuples, let us say this tuple is not a part, right? or let us say x determines y holds here. So when we will say that x determines y holds here, we say whenever there are two tuples t1 and t2, whenever their x values match, their y values also need to y. T1 of y is equal to T2 of y. T1 of y is equal to T2 of y. True? Right? So then we can say that a functional dependency holds, right? Whenever the value of x repeats, the value of y also repeats, right? So that is how we can determine the value of y, right? If x repeats but y doesn't repeat, x is repeating, right? X is becoming again 1, but y is not repeating, then we cannot uniquely determine the value of y, right? So the functional dependency fails to hold, right? So what is the definition of functional dependency? That whenever two tuples agree on their x value, they must agree on their y value. That is what is written here again. X functionally determines y in a relation schema if and only if whenever two tuples of R, what is this? Relation instance of a particular relation schema, capital R, agree on their x value, they must necessarily agree on their y value. Whenever two tuples agree on their x value, they must necessarily agree on their y value, right? So that is what a functional dependency says, right? We also say that the values of x component of a tuple, it can be uniquely determined by the value of y component of a tuple, or the value of y component of a tuple can be uniquely or functionally determined by the value of x component of a tuple, or there is a functional dependency from x to y, or y is functionally dependent on x. So these are various ways in which we say that a functional dependency holds, right? So what is functional dependency? Functional dependency between two sets of attributes x and y say that given a value of x or given the value of x, we must be able to uniquely determine the value of y. And how is it possible? It is possible whenever x value of x repeats, the value of y also repeats, because if that is not the case, then given a particular value of x, we will not be able to give a particular or unique value of y, right? So what is the condition? That if x repeats, then y also repeats. If the value of x repeats, then y also repeats, right? So that is about the functional dependency, right? So this is a very important concept, you need to know this, okay? So that is about it. And let us say if it is given that the value of x, or if a constraint on the relation schema states that the value of x cannot repeat for more than one tuple, or there cannot be more than one value, there cannot be more than one tuple in the relation schema with the same x value, right? What I mean to say is, if a constraint on this relation schema, let us say R, states that we cannot have same value of x for more than one tuple, that is x does not repeat, right? So let us say x cannot repeat, x can be 4, 5, 6, but x will never be 1 because the value doesn't repeat. Then what it means? It means that x can be the candidate key, or x is the candidate key, right? What I'm trying to say is, if a constraint on a relation schema states that the value of x attribute, or the value of x cannot repeat for more than one tuple, then what it means? X is a candidate key, right? So it means that x is a candidate key. Why? What is a candidate key? Candidate key is the one which we can use to uniquely identify every tuple in a relation schema, right? So since the value of x is not repeating for any two tuples, given the value of x, we can uniquely identify a particular tuple, right? So x is a candidate key, then x determines y for any subset of attributes y of the relation schema. What I'm trying to say is, let us say x is a candidate key, right? Let us say x is a candidate key, or let us say the value of x cannot be the same for two tuples. The value of x can be not be the same for more than one tuple, right? So then x is a candidate key. If x is a candidate key, it can determine any subset of attributes. Let us say we have 4 more attributes here. Let us say z, a, b, right? So given a value of x, we can determine the value of any particular attribute. Why not? Because it is a candidate key, right? X is a candidate key. So what is a candidate key used for? Candidate key is used for identifying every tuple uniquely, right? So given the value of x, we can uniquely say the value of a, or uniquely say the value of b, or uniquely say the value of these two, or all of them, right? So x determines y holds for any subset of attributes y of R, right? you can write it if you like, that if a constraint on R states that there cannot be more than one tuple with a given x value, that is x is a candidate key, then x determines y holds for any subset of attributes y of R, right? So that is about it. Also, a functional dependency is a property of the attributes, right? It is a property of meaning or semantics of the attributes, right? What I'm trying to say is, let us say I have a relation schema student, right? I have a relation schema student and it has roll number and then name and then address and so on, right? So what is the meaning of roll number? Roll number means that every student will have a unique roll number in a particular class, right? So let us say this is a class relation schema, right? So then roll number can determine any, can functionally determine any attribute or any subset of attributes. Why? Because it is designed like that, or it is the meaning, inherent meaning of the attribute roll number, that it can determine any particular value of a particular attribute, right? Let us say I say roll number 2's name. It can uniquely give it to me. Why? Because roll number is designed in such a way that it has to be unique. How is it possible, or how we concluded that? Because it is the inherent meaning of roll number attribute, right? So functional dependency arises from the inherent meaning or semantics of the attributes, right? So also the relation extensions or relation states that obey the functional dependency constraints are called as legal relation states or legal instances, right, or legal extensions, right? So if every relation instance of a particular, or if any relation instance of a particular relation schema follows the functional dependency constraints that are specified on a particular schema, then it is called a legal relation state, right? Also, a functional dependency is a property. Keep writing whatever properties I'm saying. A functional dependency is a property of a relation schema and not of a particular relation instance. Okay, what I'm trying to say is, just like key attribute or primary key is a property of the entire relation schema and not of a particular relation state. Similarly, a functional dependency is a property of a particular relation schema and not of any particular relation state. What I'm trying to say is, let us consider this particular relation schema teach, right? It has three attributes: teacher, course, text, right? So we say that, let us look at this: text determines course. Is this possible? Is this functional dependency possible on this? Let us say text determines course. Yes, text can determine anything. Why? Because the value of text is unique, right, for every tuple. So text can determine anything. So text can determine course also. Whenever left hand side value is unique, it can determine any set of attributes, right? Just remember this. Whenever left hand side of this functional dependency constraint is unique, whenever it has always unique values, then it can determine any subset of attributes, right? That is what we discussed here, right? If it is a candidate key or if it has unique values, then it can determine any subset of attributes, right? So this can be possible. Does teacher determine course? Given the value of teacher, can we say the value of course? No, because given the value of teacher as Smith, we are unable to give the value of course uniquely, right? Uniquely is important. Definitely we'll be able to give some value of course. We'll be able to say DS and DM. Let us say, given the value of teacher Smith, can we say the value of course uniquely? No, because given the value of teacher as Smith, what is the value of course? DS and DM, right? So it is not unique, right? So this doesn't hold. This dependency does not hold, right? Teacher doesn't determine course, because given a value of a teacher Smith, given the value of teacher attribute as Smith, we are unable to uniquely determine the value of course. It is giving two values, DS and DM, right? So this functional dependency doesn't hold. What about this functional dependency? You may try to say that since text is determining course, since here given a value of text, we are able to uniquely say the value of course. Let us say text is given as Bartram. So then the value of course is DS. If the value of text is Horowitz, then the value of course is DS, right? So given a value of particular text, we can uniquely determine the value of course. So you can say that this functional dependency holds here. But this is not right. Why? Because we cannot say that a particular functional dependency holds just by looking at a particular relation extension or relation instance. Why? Because let us say this relation instance now changes. Let us say we have one more a tuple added to this, and let us say it says that Bartram, and let us say compilers. Let us say this kind of an instance or this kind of a tuple is added. Then given the value of text, will you be able to find the value of course? No, because another tuple is added and it is saying that the value of text is Bartram and the value of course is compiler. So given the value of text as Bartram, we will be unable to determine the value of course uniquely, right? So the functional dependency ceases to hold, right? So a functional dependency is a property of a relation schema and not of a particular relation instance. Relation instance can change, right? You can add more tuples, right? And it may cause violation of the functional dependency constraints, right? So we can only say this if we have all the possible relation instances, and in all the possible relation instances this particular property holds, right? So it is just like that maths property. Let us say we have to prove LHS is equal to RHS, right? So if we have to prove it wrong, what we have to do, we have to just take one value and say that this property is not equal to this, so it does not hold. But if we have to prove that these two are equal, then for every particular instance of the set under consideration, we have to say that LHS we have to prove that the value of this side and this side are equal, right? Let us say I have to prove that a particular property doesn't hold. I'll just say that take this particular instance, and for this instance it does not hold. So for every instance it does not hold. Simple. If you have to prove that the thing does not hold, you have to just say one thing. You have to just give one counter example. But you have to prove it that if it holds, then you have to give. For every particular instance you have to give a proof, right? Similarly here in this case, if you have to prove that it does not hold, one is enough. For example, here teacher determines course does not hold. You have to just give one example. So what is the example? That given the value of teacher, we are unable to determine the value of course uniquely. So we can just consider that this particular FD doesn't hold. But in order for it to be proven, that this exists or this holds on this particular relation schema, you have to take all the possible relation instances of this particular relation schema and say that this particular functional dependency holds, right? So a functional dependency is a property of a relation schema and not of a particular relation state. Hence it must not be inferred automatically from the relation instance, right? And who can specify the functional dependency? Functional dependency can be specified by someone who knows the meaning or the semantics of the attributes, and then he or she can specify that, right? We cannot say that this particular functional dependency holds just because for this particular instance it is holding, right? If we have to prove that just by giving the instances, we have to have, or we have to see, or we have to check all the possible instances of a particular relation schema and say that this holds for every particular relation instance or relation states. Therefore it holds for the relation schema, right? So understood? Okay, so now I think the time is crossing, so let us continue this in the next lecture, right? I hope you understood functional dependency, right? This is a very important concept and it is very necessary that you understand it. Otherwise you might face problems later, right? So understand, so I hope you get this from this video, and we'll continue after the topics after this in the next class, okay? So I hope you like this. If you do, then please don't forget to press the like button, subscribe to my channel so that and press the bell icon so that you get notified every time I put up a new video. I'll see you in my next one.